All right, guys, welcome to our Unit 1 Quiz 3 study guide. I'm going to be going through the even problems, and those are the ones that you guys are required to do. I have included odd problems so you guys can have extra practice, and the answers for the odd ones are included in case you want to check your work. That being said, let's go ahead and get started here with number 2 here. So number 2 is an example of a double chain rule. First of all, I would rewrite that as a half power. The next thing I would do is I'd rewrite the whole thing as a 1/4 power. And what we have here is we have a double chain rule. And in class, I described it like you have the egg whites, or I'm sorry, you have the shell, which is the outermost portion of your expression. You have the yolk, which is the innermost portion of your function. And then everything else that I left there, which I guess I'll just color red. That's all part of the middle, or I called it like the egg whites. So when you're doing your derivative, you're going to be doing the derivative of the shell times the derivative of the whites times the derivative of the yolk. So here we go. Let's go ahead and start with the shell. The shell is the 1/4 power, so I'm just going to put the 1/4 here in the front. I'm going to subtract 1 from the power, and there's that. The entire inside portion is just going to stay unchanged at this point. Next, we're going to do the derivative, of the red portion. So first of all, for the red part, we have this half-powered portion. So that's going to be 1/2 times 4x plus 3. Take 1 away from your power, which makes it negative 1/2. And the 1 just goes away because that's a constant. And then finally, we're going to take the derivative of the yolk section, which is just 4. And that's probably good enough. Technically, we could simplify it a little bit, but I'm just going to go ahead and leave it like this. Okay? And that's what it'll look like on your test too, just unsimplified. All right, let's go ahead and take a look at number 4. So number 4 is an example of a product rule, because I do have two things being multiplied together, but that product rule is going to have a chain rule inside of it. So according to the product rule, when you take the derivative of a product, it's A, B, matter of fact, I think I might need a little more space here. So A, B, A, and B, prime here, and prime there. All right, so I'm going to call this part A, and I'm going to call this part B. And also, before I go any further, I'm going to go ahead and rewrite this a little bit. The 2x to the 4th is going to stay the same, plus 1. But this piece, I want to rewrite that as a powered expression instead. So I'm going to rewrite that as 3x plus 5 to the 1/4 power. All right, so that's my A and that's my B. So let's go ahead and begin here. So we have A prime. So the derivative of this thing here would be 8x cubed. Then we have B, and so it's just going to stay exactly the same. And then we have A, which is going to stay exactly the same. And then we have B prime, and that's where the derivative or the chain rule is going to come in. So my outer function for this piece is the 1/4 power. My inner function is the 3x plus 5. So we're going to be doing, for this last portion here, we're going to do the derivative of the outer multiplied by the derivative of the inner. Okay, so here we go. The derivative of the outside, that's a power function, so I'm just going to move the 1/4 to the front. And then I'm going to take 1 away from the power. and the inside is just going to stay the same. And then for the derivative of the inside, the 3x plus 5, that's just going to be 3. And there you have it. Okay. I'm curious how they're going to write the answer here. Let's take a look here. Show answers. All right. Yeah, that's exactly what I have. It's just that they put this portion first. Oh, that 3 is included. And then they put this portion second, whereas I had it reversed. But other than that, exact same thing. So that's what it'll look like. Let's go ahead and move on to number 6. So this is an example of a quotient rule that has a chain rule inside of it. So we have a quotient. So we're going to be doing low d high minus high d low. Draw a line in the square below. All right, so here we go. Low comes first, and it just stays exactly the way it looks. And that's being cubed, so that's still going to stay there also. And then we have d high, so the derivative of the top is 4. Minus high, it stays the same. And then d low, and that's where we're going to have our chain rule. So we have an outside function here, and we have an inside function here. And so we're going to do the derivative of the outside being multiplied by the derivative of the inside for this particular part of our quotient rule. All right, so the derivative of the outside is going to be moving the 3 to the front and taking 1 away from the power and leaving the inside the same. And then the derivative of the inside, we're going to get 6x squared. I'm just doing the power rule there. 3 times 2 is 6, and then take 1 away from the 3 and you get 2. So 6x squared. So we have low d high minus high d low. Draw a line, and we square the below, so that means that guy. And we'll stop there. All right. Let's move on to number 8. So now we're moving on to our trig derivatives. So hopefully you're getting these things memorized, but if not, I gave you a handout. So your goal here basically is just to find which trig derivative we're working with and use the worksheet to complete it. So here I'm working with tangent. All right. Now, anytime we're doing these trig derivatives, the outside function is going to be the trig function probably, and then the inside function will be the one that, although they're not in parentheses on there, we're going to remember I like to put parentheses there. All right, so we're dealing with tangent. So since I know we're dealing with tangent, I'm going to look at my sheet, I'm going to find tangent, and here it is. It seems that the derivative of tangent is secant squared x. Now by x, I mean whatever is here, that's going to go there, right? And it's a chain rule, so we have to keep that in mind as well if we're doing this problem. So here we go. So the derivative is going to be a chain rule. So we're going to have the derivative of the outside being multiplied by the derivative of the inside. Now the outside is a tangent function, and we just said that the derivative of tangent is a secant squared function. You're going to keep the inside exactly the same on that. Next, we're going to multiply it by the derivative of the inside. That derivative would be 4x cubed. And that's it. Let's do number 10. Okay, now we're looking at a cotangent problem. So we're going to go back to our handy-dandy sheet here. We're going to look at what is the derivative of cotangent. And it's right down here. The derivative of cotangent is negative cosecant squared. So let's go ahead and revisit our problem here. My outside function is the cotangent. My inside function is the x squared. And my goal here is to find the derivative of that function by doing the derivative of the outside multiplied by the derivative of the inside. So here we go. Derivative of the outside is derivative of cotangent, which we said was negative cosecant squared. And the inside stays the same, so it's going to be x squared. and we're multiplying that by the derivative of that inside. The derivative of x squared is 2x. And now we're done. Moving on to number 12. One more trig derivative. Let's go ahead and take a look. So my outside function is the secant. My inside function is the 4x to the 5th. Here we go. So the derivative secant, we'll look at your reference sheet and you should be able to find it. The derivative secant is secant tangent. And what goes in those blanks is the 4x to the 5th. All right, last one we do the derivative of the inside, which is 20x to the 4th. And that's that. All right. So moving on, our next one we're going to look at is a arc trig function. You could tell these are arc trig functions. In other words, inverses of the other trig functions. Because there's that little -1 there, that means we're dealing with an arc trig function. They have different derivatives, so we'll look at it. But once again, it's going to be an outside function and an inside function situation there. So outside is the orange, inside is the red. Let's go ahead and take a look at our cheat sheet here. We're looking for the derivative of arc secant. That's on the bottom here. These are the inverse trig functions, also known as the arc trig functions. I'm using different notation here. Rather than secant with a little -1, I'm using arc secant. It's the same thing, though, just different ways of writing it. So it seems like the derivative of arc secant is 1 over the absolute value of whatever's here, and times the square root of that value squared minus 1. All right. So whatever's here goes in these two spots down here. The rest of it stays just as it is. So let's go ahead and go back to our problem and apply that now. Outside, inside. Okay, so for the derivative of the outside, the derivative of arc secant is going to be 1 over the absolute value of the inside times the square root of the inside squared minus 1. So my inside is x to the 5th, so that's going to go here and here. Next, we're going to do the derivative of the inside function there, which is 5x to the 4th. All right, now, with these, we might have to simplify a little bit. First of all, this is an odd power, so we want to keep the absolute value bars. If you have an even, you can get rid of those absolute value bars, but since it's odd, we got to keep it. We talked about that in the lesson. Right here, we have a 5 times 2. That's going to be 10. So the bottom now is going to look like this. The absolute value bars are staying. And now this is going to become x to the 10th power because we do the multiplication of the powers there. And this guy over here, you can think of that as over 1. So top times top, bottom times bottom. That's basically just going to end up putting that thing up there. Okay? And so that would be this most simplified version of the answer. Let's go ahead and move on to number 16. So now we're doing arc cosecant. All right. So my outside function is the arc cosecant. And my inside function is the negative 5x to the 3rd power. So the derivative of arc cosecant is just like the derivative of arc secant, which we did earlier. The only difference is that there's a negative on the outside. This time what goes inside the brackets and parentheses is the negative 5x cubed. And then over here on this last one, we're doing the derivative of the inside, which is negative 15x squared. Okay? So simplifying this, this times this will give me 15x squared. The bottom, once again, since the power is odd on this piece here, we're going to keep the absolute value bars. And then under here, we're going to square that negative 5, so that's going to become positive 25. And then we're going to square that x cubed, which makes it become x to the 6th. And so that would be the most simple way to write your answer on that one. All right, let's go ahead and take a look at number 18. One more arc trig function. We've got arc cosine. So when you want to find the derivative of arc cosine, that's the pattern we're looking at there. So derivative of the outside times the derivative of the inside. The outside is arc cosine. The inside is 5x squared. So as we just said, the derivative of arc cosine is negative 1 over the square root of 1 minus whatever's on the inside there squared. In this case, 5x squared is the inside. Our derivative of the inside is 10x. Okay, so simplifying this, we multiply the 10 to the top, and we get negative 10x. And then on the bottom, we're going to square the 5, and we get 1 minus 25x to the 4th power, because you also square that x squared. And that would be our final answer there. All right, let's go ahead and move on to number 20, dealing with a natural log. Now, when it comes to natural logs, your outside function in this case will be the natural log itself, and your inside function will be the x to the 5th. So when you go to find your derivative, the derivative of the outside will be 1 over whatever the inside is, in this case, x to the 5th. Then, when you multiply that by the derivative of the inside, that one's just a simple power rule, so you get 5x to the 4th. We're going to multiply that to the top, and we're going to end up with 5x to the 4th over x to the 5th. And we can reduce this x to the 4th with x to the 5th, with leaving 1 down there. So the final answer would be 5 over x. Take a look at this one. When it comes to exponential functions, the outside function is the e, and the inside function is the power. So if I want to find my derivative, we're going to do the derivative of the outside. Now the derivative of e is whatever it was originally. It doesn't change. So this is the derivative of the outside. It stays exactly the same. The derivative on the inside, however, we're going to do that now. 2x to the 5th power, we're going to do the power rule. We're going to put 10x to the 4th, and there we go. This is another log, but this is not an ln. This is a log of a different base. In this case, the base is 5. So when you do these types of derivatives, once again, you have the outside and inside function. The outside function is the log base 5. The inside function is the 5x squared. So when you take these derivatives, the derivative of the outside is going to be 1 over the inside. Actually, I think I'm going to put that a little bit differently. 1 over the inside. I'm going to move it over here to this side. Multiplied by ln of whatever this number is. So in this case, it's 5. So that's the derivative of the outside. Now I'm going to multiply that by the derivative of the inside, 5x squared. That derivative would be 10x. We're going to multiply that to the top to simplify it. 5 goes into 10 twice. Oh, I forgot my x. And x takes one of these x's off on the bottom. So on the top, I'm left with 2, and on the bottom, I'm left with x ln of 5. Right. Go ahead and take a look at number 26. This is another exponential function, but it's not an e function. It's a little bit different. It's a 5. So With these, the outside function is the 5, and the inside function would be whatever the power is. So let's do our derivative. The derivative of an exponential function that's not base e can be found by just writing the whole thing again, but with an extra caveat. We're also going to multiply it by ln of whatever your base is. In this case, it's 5. That's the derivative of the outside. Now we do the derivative of the inside. That would be 8x. And that's our final answer. Once again, make sure you guys are looking at your FRQs from last weekend. There will be one question like those on your quiz, and this one will be worth about 20% of the quiz score this week. So, hope that was helpful. We'll see you guys in class.